No. Yeah. No. Stop. Come here. Come on. It's right there for you. Come on. No, you stay over there. That's for you, though. Evening, folks. Hopefully this can be heard pretty well. I'm going to be doing the stream a little differently tonight, since we're so close to being done. So give me one moment to get that set up. Alright. Then... whoops. We'll do that for now, and then we'll move the light out of the way whenever autofocus. There we go. Isn't that pretty? Alright. Your stream, huh? I was busy. But, anywho, oh yeah, Kitty right there. Kitty's obnoxious as always, but she's happy because I gave her a nice little chair, and she just likes to be close and know that she's loved. Then she calms down most of the time. All right, so we tried a full-size HDMI cable, and it kept the battery kept basically having issues with the bracket right there. So, with Crash's approval, we purchased a new HDMI cable that doesn't have that metal bracket. So, come on. That fits nice! Give me 1 second. How can I offset this? So I need to go that way, right? Da-da. Oh, no, other way. My bad. 1 second, let me move my fan, because I do have to do some soldering, just not a whole lot. Alright. Is that zoomed in? I can't tell. Give me 1 second. Ah, yes, it is. No, it's not zoomed in, but it's kind of zoomed in on the stream. Deal with it. Alright. So. Cat's gone. Whenever I pulled this back apart, I accidentally pulled some wires off. And that's just with my little junction box there. So I gotta fix that. And I may have forgotten a wire on the status board, so I have to tear that back out and solder up one more wire to it. I believe that's why none of my LEDs are coming on. So, but let's well, actually, we'll save, just because this is ribbon cable. We'll save this for a little bit. We'll solder and crap in a little bit. I want to get that Teensy programmed, which is going to actually be the hardest part, because I've got to learn how to do it over RetroPie, because I don't have a USB male-to-male cable made. So we'll come back to the hardware side unless I have a guest stopping by, more than likely, and I was going to show him how the audio for this works. But until then, we go software. Hey. So that's why I have this set up a little different, is so that I can boot this. Well, hold on, before we turn any power on. I don't want to put any more stress on that ribbon cable than I have to, so until I'm ready for it, I'm just going to use this. So one in. To it. Alright. That'll center just nicely. And because nobody wants to see, you know, upside down. Mirror and flip. Bada bing, bada boom! Alright, so let's move this light off. Oof, I am so sorry. I swear, it's not actually that dark, it's just that we're outside of the field of view of the screen. Oh, isn't that a sexy beast? Alright. So, I do have the USB to that. I just don't want to chop up a data cable. Nor do I know where any are, because my wife has kind of packed up a crap load of my stuff. But yeah, it uses the male here, so to actually get it to connect, you have to have basically. That's hilarious. Cat just jumps in the chair and it turned around on her. But to hook into it, basically, you gotta have two of these guys on a cable. So they make cables for it. I could make one if I had spare cables to do it. Well, I has an idea. Yeah, because over USB, I have no problem doing this. I've worked with Arduino in the past. I just have to look up the code. But yeah, my wife damaged this cable, so I don't feel bad chopping it up. Which I do feel bad chopping it up, but not now that she damaged it. I just wish she hadn't. So we will save that for a project that needs a USB-C connector. And this cable, my wife crushed in a dresser drawer and broke the cable farther down the line, and I just don't feel like repairing it. Alright, so we got 4 USB. Now there is another cable I gotta find real quick. Ah, there it is. When the cable says, "Am I dead?" The cat killed it. So, alright. Yes, you killed it. Because you suck. Alright. Whenever she gets angry, even though she knows there's repercussions, she destroys cables. So, there's another one gone. But it's her way of communicating to us, "You made me angry." I wish you could communicate better. We gotta work on that. Alright. So... Alright, that'll work. Well, on that note, let me slide some shrink tube on. And we're going to turn the Pi off for now. Alright, that cuts power to the screen, everything. So. Alright. Now, Crash, I'm probably going to have to make you a cheat sheet for all this. But programming like the Teensy, if you ever do, it'll have a very specific order everything has to be done in to safely, well, not safely program it, but to program in it, not just derp out on you. Because since I don't have any diodes in there, I believe that means the Pi and Teensy are sharing power, technically. And what that would do is if you supply power to the Teensy to program it, by default it would turn the Pi on. So that means you can't just simply turn off the main power and turn the Pi on, or not turn the Pi on, turn off the main power and plug up the Teensy to your computer. As goofy as this sounds and as backwards as this sounds, you would have to turn on the main power, shut down the Pi, like to where it's a soft off, and then you could program the Teensy. As goofy as that sounds. So I'm just going to make a little cheat sheet of how you got to charge, how you got to program, stuff like that. when you really don't want to learn how to program a Teensy on a Raspberry Pi. Honestly, I could deal with programming the Teensy on the Raspberry Pi. What I don't want to deal with tonight is programming a Teensy on a Raspberry Pi over SSH, because that's how I'd have to do it. Okay, Braden, I just got your message on Facebook. I'm guessing you're here at the moment. If you are, I'm about to show you the sound. Give me one moment to braid these up. I'll solder them in a minute. Because Crash, Braden's making a Game Gear Pi, so I was going to show him how the sound is set up on this one. Which I haven't looked at your PM, Crash, but I'm guessing you probably found a stereo I2S, which, awesome, because I'm definitely going to use that in the future. It just makes it to where you only have to fit in one component instead of two. Alright. So, Braden, if you are watching at the moment, give me 1 second. I'm going to move to where I can see the webcam in live real time. Alright. So, let me turn down the sound. Alright, cool. Alright. So with the way we did the sound on this one, Braden, it's a Wii U Pi for Crash. So, mind the mess. Okay, so mono is good. Well, that's cool, because we're actually set up in mono on this one. Even though we have two speakers, we're set up for mono. So, the, let me... One second. There we go. That gives me a little bit more breathing room. Alright, so, on this hot mess, we're using an I2S soundboard, which Adafruit has a website, well, Adafruit has a website. Adafruit is a website. Adafruit has a page on their website for the I2S that they sell, which that's what this guy is. But then, the way I have it wired up for this, it goes from the Raspberry Pi of the GPIO over to the Adafruit I2S sound card. This outputs in stereo. There's another alternative I'll show you in a moment, but it goes from here. Now it's amplified enough to go to headphones, but it's not amplified enough to go to speakers. So it goes from here to this potentiometer. This one right here is a 5-pin 10K potentiometer. I would recommend something lower if you can find it, because to change between the max and min volume, it's only a little bit of a movement on this one. So if you can find a lower resistance, get a lower resistance. But it goes from here to this 5-pin stereo headphone jack. Because what this guy is designed to do is it takes, which there's different ways to wire these up. And I can't remember who it is that wired it up this way, but I just have the pins bridged, so it converts it to mono. I actually bridged them back at the I2S board, so it goes from the I2S board to the volume wheel, then from the volume wheel to the headphone interrupt jack. That way whenever you plug your headphones in, it disconnects from the speakers. But then it goes from the interrupt jack over to the mono amp right here. Mono amp goes to the speakers here and here. That's the best way I can think of if you want a physical volume wheel. The other option is if you wanted to do it over software, um, but you'd have to either set up some kind of a shortcut on your joypad where you can press a button and turn the volume up and down, or you'd have to have like a mouse and keyboard and actually go in and up arrow, up arrow, up arrow, down arrow, and you can do soft volume controls through the Raspberry Pi. Doing it with the Raspberry Pi to the I2S actually works very well. This is just set up to where you can easily set it physically and it adjusts the volume on a physical level rather than a software level. Any questions? And did I lose you? Then while I wait on the stream to catch up, going back to working on this cable. I got you. Because there's a test. You're going to pass, right? No, I'm kidding. But yeah, if you have any questions on it, I can easily help you whenever I'm not streaming, obviously. Okay, so mine was because I was originally going to do stereo. Okay, Crash says emulation station has sound control. But Braden, to answer your question, I was originally going to do stereo, so we had to find a stereo volume control wheel. But since you're doing mono, you can actually just search for a volume wheel potentiometer. All you need is a 3-pin. You don't need a 5-pin like what we have. The 5-pin allows it to where you can adjust stereo sound up and down, not independently, but without crossing channels. But it'll actually say what the resistance is. It'll say, oh crap. This one's a 10 kilo ohm resistance. So if you can find something like a 1 to 5, that'd actually be your sweet spot, I'd say. But yeah, Crash was finding me something for the next project I work on, or sometime in the future, I'm sure, that I thought was pretty cool. But it wouldn't work if you wanted to do headphones and speakers. It would have to be it would have to be sound speaker, no headphones. You could still do a volume wheel, you just couldn't have the headphones on it. And that would take the component down one, or component count down one, because it actually puts the I2S board and an amplifier all in one board, which is awesome. Actually, we'll put these on after we pretend. Turn my fancy dancy soldering iron on. Yeah, I think they're higher because they're more designed to go post-amp rather than pre-amp. But the problem is if you do it post-amp, you can't volume up and down the headphones as well. So I don't know how they do that. I'm not an expert, I will say that. This particular mono amp is a PAM Papa Alpha Mic 8302A, and then I think there's an 8304A is the stereo version. So there's two different amps, almost identical. It's an Adafruit design, but they there's a knockoff that you can find on eBay, and it's a lot cheaper. So definitely check eBay. Crash, I'm sorry if it feels like a one-sided conversation. Why is it intimidating, Michael? Alright, what was I doing? What did I do? What did I do, Crash? And why am I one? I'm confused. Oh, one-sided conversation. Gotcha. Well, I thought about messing with you and go, you know, Crash, I'm not feeling too good. I think I'm going to go to bed. Hey, Michael, I mean, just keep working on technique and following videos. I will say not all videos are beneficial because some people, like whenever I was first trying to learn, there are some people that give lessons that shouldn't be giving lessons. So I'm not going to pretend to be an expert by any means, but I do think I know a little bit more than average. So if you have any questions, feel free to ask. I can tell you the one I actually learned the most off of was probably from Joseph Jones. So, alright. Oh, that's perfect. Alright. Let's make some cables. I hate making cables. Alright. I need another piece of solder. Now, for the record, I will be soldering these at a slight off angle on purpose because the independent wires that I'm actually soldering together, the heat shrink over top of them, is too small for. Not the power wires. Power wires are just fine. But the data wires are a slightly different story, so I'm just giving a little bit more for the heat shrink to grab onto. Don't try this at home, kids! This is gonna hurt. Nope, I missed. Cool. On which part, is it Braden? Hope I pronounced it right. Because there's a lot of power and ground hookups. A lot. That being said, anything with sound, I'm pretty sure, yeah, with sound, like to the I2S board, no, everything. Yeah, everything I like to run back as close to the power source as possible. That's just a personal preference. If that's what you're talking about, like the, obviously Raspberry Pi, it gets its own power just because it's one of the highest current drawing things. But if that wasn't the case, I wouldn't be worried about it having a dedicated power line. The things that I care about having as close to the power source for ground and having each having their own home run ground is the amp and the I2S card, and that just helps eliminate RF noise. So. Give me 1 second, I'll show you what I mean by that. Let me heat shrink some cables. There we go. And 280, way too hot. Well, not way too hot, but kind of too hot. Let's go 200. 200. Give me 1 second. Alright. There we go. Then, where'd my heat shrink go? Oh, there it is. I think it's called a 5-pin stereo headphone jack. I think, therefore I am. Yeah, well, screw it. I tried to keep it all nice and fancy. Heat shrink's a little too short because the mesh pulled back, but I give you the entirely ghetto USB male to male cable. Okay. On that note, back to the software side. Alright. So we will cut the Pi on. Alright. But then, let's see. Okay. That's what you're looking for, Braden. So what happens is when you put the jacks in, it disconnects it from the outputs. Alright, now I've okay, that was fun. I forget which one of those pins is power. I think it's the red one. So instead, I'm just going to shut it down over SSH. But which way do I have you set up to go in? There it is. Okay, cool. For now, I'm going to turn off my soldering iron and turn off the fan so I don't accidentally chop my fingers, because it sucks. Alright. So, let's see. Alright. Okay, so first thing we're doing is we're doing sudo shutdown now. Actually, give me 1 second, see if I can't get a copy of my terminal up on the screen. That way it doesn't, feel like, oh, I'm looking at one screen. Blah blah blah. Yay! You know what, Bobby? Alright. So let's see. Let's try game capture. Create new. Capture a specific window and putty. That should work. Maybe. Maybe not. Maybe it has to be full screen. Hmm. Um. Okay, let's delete that one. And isn't there window capture? There is window capture. Um. Yeah. So there we go. Hey. All right. There we go. Except for that. Ooh, no. Sorry, I'm having technical difficulties. Ooh, that's trippy, ain't it? Ooh, that's so trippy. There we go. Well, once I... Okay, so sudo shutdown now, blah blah blah, and then bada bing, bada boom. Okay. So I'm guessing... Well, actually, I'm kind of curious what this streams whenever I'm not looking at... Oh, okay, we're still on that. I'm waiting for the stream to catch up. I want to see what it looks like. So, hey, that doesn't look bad. Just waiting for OBS, well, rather eBay to catch up. Alright, I'll look at that after. Okay, so it does basically capture what I look at, which is hilarious because that is so broken, OBS! You're only supposed to capture that specific window. But whatever, I don't care. Alright, so... Alright, do I still have the Arduino library loaded? No. Wait, maybe. Open folder location. Yeah, I do. Cool. Yeah, go ahead and update. Oh, okay, so basically, hey, update means install it again. Cool. Just download. Alright. So give me a minute to install that. Yes, I agree. Blah, blah, blah. Nothing I care about. Install. Oh, wait, wrong board. Okay, do I need to do... Yeah, go ahead and install your fake ports. Oh, hey Crash, look at this. This is based on his numbers. That was with a Raspberry Pi 3. I don't know if the 3A Plus is more energy efficient or if it's more juice hungry, because it does have a higher clock processor technically. Well, once we set it that way, it's a higher clock processor. But oh, will you just stop? Okay. If it asks me for one more thing. Okay. For better analog input in N64 games, change any instances of 1.8 like in here to 1.5. The analog range is going to be shorter, hence joysticks is not so sensitive. RetroPie is still able to register analog on setup screen, but unfortunately you'll lose analog movement in PSX games. Well, I mean, you're mainly using it for the computer, so that shouldn't be an issue. Home button action modified to switch between joystick and keyboard. Okay, cool. Cool. Okay, close Arduino. And where's the Teensy library? This is actually my first time programming a Teensy, so give me 1 second. I might have to download the libraries separately. Or okay, give me 1 second. I just don't care about that. Because the Teensy should be talking to it right now. Yeah, that's why the LED isn't blinking. Okay, you're breaking my stream, man! No, I appreciate it. Yeah, I literally just got there right as you sent that to me. Alright, downloads programs, once you run them, when you use Arduino, this will be done automatically. But doing it manual is a simple way to check that your board works, blah, blah, blah. Yeah. Installed. Oh, Teensy Arduino. Okay, it's a dependency. Cool. So I probably have to close this and this. No. I already have the Arduino. Linux only. No. Ah, here we go. No. Yeah. On Windows, this driver allows you to access a serial device type. This step is not. Yeah. Is that all I need? Oh wait, here we go. Nope, not what I need. Okay, cool. Choose the board. Okay, so yeah, it should just add the boards. Next. Alright, now I can open Arduino. No, it's a Teensy LC, isn't it? Yeah. Helps if you plug in the actual board. I'm retarded. I'm going to mute the Windows capture for a moment. Okay. Crash, I messaged you on Facebook. Alright. Gotcha. Okay. You're good, Crash. Alright. No, come here, you little button, you. You little button. For the record, I did eat paint chips as a kid. True story. I wonder if I have the pass-through plugged in. Well, yeah, I would have had to have, otherwise my microscope never would have came on. Excuse me. Alright, I'll do the proper step-by-step. Sorry, it's been a while. I think it's a Teensy LC, but I'll verify my purchase here in a minute. They're kind of the same thing, but I think it's just different memory. Alright. The hardest part is actually getting Windows to talk with them. But give me 1 second, I'm going to pull up eBay. I think I purchased it on eBay. Well, actually, I have it on docs.google.com. Except for my wife last signed, no? No, she didn't. Oh, sheets. Sheets.google.com. It says Teensy 2.0. Oh yeah, it is Teensy 2.0. I thought it was Teensy LC. Why was I thinking LC? I don't know. Anywho, thank you. Alright. Board. Teensy 2.0. Alright. Sure. Joystick was not declared in this scope. Now I gotta open Teensy 2.0 code and wiring. This was last edited on 2016, so I wonder if there was some library changes since then. Alright, verify. If digital read equals low, joystick button 1. Now I gotta score through the Hey Crash, actually, do you mind looking through this and see if you can find anything about someone getting this error while trying to compile? I'm sure it would probably be in the later pages, but I'll get back to that in a minute. I'm trying to verify that the boards are talking. Digital plate. Alright, blank. Pin 11. Verify. I am a whole kind of special. Not the script part, but the fact that I was trying to program a TT without having the USB hooked up to the TT internally. This should get them talking to each other. Alright, now let's see what you do. Alright, tools, get board info. It says can't obtain. Alright, let's put you in program mode. Alright. USB device not recognized. That means probably tucked on a wire. Okay. Unknown device. Yes. Alright, tools, get board info. Alright, now let's programmer. And my computer is being really stupid. I have a feeling I need to reboot my computer to make this work. Alright, I'm going to restart the stream. I will be right back, guys. Well, rather, I'm going to restart my computer. And then I'll restart the stream. But I'm not going to stop it, so it should, once I restart OBS, it should just pick right back up. Alright, test. Okay, I can see myself again. So... Alright, so let's get some more music going. Make sure... Alright, so we're not slow. I just can't hear anything. Oh, it's because there's hardly anything there. Alright, so right now, no serial port. Alright, USB device not recognized. It does not malfunction, you idiot. It's probably just because I ain't got it in programming mode. It does not malfunction. Windows is just retarded. Because if it had malfunctioned, this wouldn't be reading. For giggles, I'm gonna cut main power for now. Yeah, I figured that would do that. Okay. So, again, this is just for giggles, but I want to make sure that the Pi isn't somehow causing a problem, and if it is, I just have to put in that toggle switch back behind the antenna, which, yeah, I don't want to do. I want to close this guy up tonight, but alright, that's the ground plane. That's fine, the ground can stay connected. So, as long as we get those data pins off. Now I swear, if this is all that's causing the issues, I'm gonna be pissed. USB device not recognized. Of course not. No, I left the default crash. Yeah, I think it's 1, at least for that. Okay, I'm wondering if it's the drivers. One of the USB devices attached is blah blah blah. Because I have a feeling it's one of the COM port drivers I have is conflicting with one. I have a bunch of different hardware set up on here. You know what? Screw it. I'm gonna watch a quick video real quick on trying it with the Pi. Because if I can't get the serial on here to work, I might be able to get it to work on the Pi. So. Raspberry Pi program Teensy. Because I've also got a different computer to try it on too. Because I've had issues with my USB controllers before. AFK for a little bit. There we go.
Motors, we basically can use this device to interface with the real world. So what we're going to do is get this set up to be programmed using the Arduino IDE, which is an open source IDE that is used for programming a lot of different microcontrollers that support the order for the Teensy microcontroller. Them if you want, but of course we're just going to skip that for now. We'll click just download, and then we'll wait for our download to complete. Once the download is complete, we can extract our IDE files to begin the installation process. The archive is in a XZ format, which is a type of compressed file format similar to zip. In order to decompress it or to extract those files, we're going to need to use the tar program. Tar is a program that supports a bunch of different file compression formats. It's very popular for Linux, and we can use that to extract the XZ file. So in order to do that, we're going to invoke the tar command, and we're going to pass the XF flag that tells it to extract using the X compression scheme. And then it's going to be in our downloads folder, and then the archive is named Arduino 1.6.11 Linux arm.tar.xz. So basically the XF flag there is telling it to do the extraction on an XZ file. So once we put that in there, this line, if I were to invoke it just like this, it would extract all those files into my downloads folder. But I actually want to go ahead and extract this into my home folder because I'm going to run the installation process from there, and I want to keep all those files there for the future rather than being in the downloads folder. So I'm going to give the capital C flag. That means to change the output directory, and then I'm going to issue the home directory symbol there, the tilde and the slash. So basically this entire line says take this tar.xc file, extract it using the XF flag from the tar program, and then I want that to go in my home folder. So I'll go ahead and hit enter to invoke that command and run the extraction process. The archive will take probably 20 to 30 seconds, maybe up to a minute to extract because it's a little bit large, so we'll wait for that to complete. Once the file has been extracted, we're ready to begin the installation process. So what we need to do, number one, we have to install the actual Arduino IDE itself, but we also have to include some files specific to the Teensy microcontroller so that we can compile our programs and run them on the Teensy board. So in order to do that, we need to go to Teensy's website, and we need to get what they call Teensy Duino, which is just a series of support files that support their boards. And then we also need to add something called a udev rule to our system. Udev is a system that the Linux operating system uses that basically provides permissions to pieces of hardware and processes that run in your system. So eventually what we want to do is run our Teensy board as a USB serial port, and in Linux we have to provide permissions to do that. In other operating systems like Windows and Mac, it just automatically trusts a USB device when you plug it in and no permissions are needed. In Linux, you could go ahead and run your program that uses the serial port with sudo, but instead of typing sudo every time, we just want to go ahead and include the udev rule. So first, to install the Arduino IDE, we need to go to the directory where we extracted the files, and that's going to be in the home directory in the Arduino folder. So if I cd into that directory, and then I issue an LS, I can see here that there's an install script that they provided. I need to run this script as sudo, so I'll issue sudo and then install.sh, and then I'll begin that, and then this will go and actually install the Arduino IDE into my operating system. So basically it's taking all of the extracted files and it's registering them with the operating system so that I get a desktop shortcut. start menu shortcut and all that. Once the installation process is complete, we can click on the Start menu, go to Programming, and we can see we have an entry for Arduino IDE. So from this point forward, we can launch the Arduino IDE program by clicking on this button. If you go to the Teensy manufacturer website, you'll see a link here called Teensy Arduino. That actually has all of the installation instructions that I'm referring to when I talk about the UDEV rules and all that kind of stuff. So you can go through this and you can download the files, and you can scroll around here and find out how to actually install the UDEV rules and do all that. But to make things easier, I've included a script on our GitHub repository that will do all this for you. So feel free to go and click on the download and install link if you want to manually download and install the Teensy Arduino files into the Arduino IDE. But I'm just going to use the installation script right now just because it's easier. So to access our installation script, we will first have to clone our GitHub repository like we've done before. So we'll go ahead and issue the clone command. Once the repository has been cloned, we can go ahead and find the installation script. So we'll issue ls. We're going to go ahead and cd into our directory, and it should be in the Teensy folder here. So we'll cd into the Teensy folder, and there's a sh file, install teensy.sh. So in that script, I've programmed it to automatically go to the Teensy manufacturer website, download the UDEV rules and all that stuff, the Teensy Arduino installer, and to execute all that stuff automatically. So to invoke it, all we need to do is issue sudo sh and then the name of the script, which is install teensy.sh. So we'll go ahead and execute this. And you can see here it's performing the download of the Teensy Arduino installer. So we'll allow that to complete. And now it brings up the actual installer GUI. So here we have the Teensy Arduino installer. So what this is going to do is go to where we extracted our Arduino IDE, and we need to tell it to find that directory. So that's why we moved it to the home directory, to be easier to find. So we need to tell it where to find the Arduino files that we extracted. So we'll go ahead and tell it where it's at. It's going to be in the home directory. It's going to be in home, pi.
Hey guys, I'm gonna end the stream for now. While I learn a little bit more about trying to program this Teensy. I just hate learning and streaming because I don't feel like I'm really showing anything. Um, Obviously, once I get it programmed, I'll say, hey, this is what I have to do, blah blah blah. Um, but until then, I just feel it's kind of pointless for me to just stream nothing. All right, so I'm gonna end it for here, and then I may or may not be back on tonight. Um, but once I get this Teensy programmed, it'll actually be pretty straightforward from here. So I think it's my hardware that's causing the problem, so I'm gonna go try it on my wife's computer real quick. Actually, I'm probably gonna try it on a laptop first, and I'll see what I get. I'll let you guys know, and I'll catch you next time, whether it's tonight or tomorrow night.